we will discuss Cauchy's integral test. If f of x be any non-negative, non-negative means positive, and monotonic, decreasing function of x and un is f of n, then series human and integral converges or diverges together for all x belongs to integer and n belongs to natural number. Strictly decreasing, strictly increasing means we have when greater than or less than. Monotonic increasing or decreasing means we have equality also. In case of fractions, monotonic. If series is in decimal form increasing or decimal form decreasing, then we have monotonic. If series is in integers form increasing, decreasing, then it is strictly increasing or strictly decreasing. If un can be integrable, then we use Cauchy's integral test. If un contains x, then Cauchy's integral test is not applicable. If un contains x, then Cauchy's integral test is not applicable because we have to make x in it. We can't integrate factorial, so if un contains factorial, we can't apply Cauchy's integral test. Also, if we have increasing multiple terms in un, that is, if increasing multiple terms are present, we can't apply Cauchy's integral test. If we have terms like 1 over n plus 1, n plus 2, n plus 3, we can do it by partial fraction. But if we have n terms, then we are unable to solve it. How can we do it by Cauchy integral test? If we can integrate un terms, then we use Cauchy integral test. If un can be integrable, then we only use Cauchy integral test, otherwise not. In log questions, we have to take limits of integration from 2 to infinity. In simple questions, we have to take limit of integration from 1 to infinity. If answer of integral is finite, then it is convergent. If it is not finite, means infinite, then divergent. And given series is also divergent. If we have x terms, if we have factorial terms, if we have increasing multiple terms, never use Cauchy's integral test. See one example. Only in this test, we have to use integration. Otherwise, in previous tests, we don't use derivatives, integration. So, we have to remember only test, result of test, and apply it. So, these are very easy questions. examine for the convergence or divergence of the series the first part. Here UN is we have to suppose it as f of n. We have to suppose it as f of n. We can also use comparison test here. We can do it by a comparison test also. Now, according to statement, you have to convert or replace n with x. Replace n with x. Check. Function should be non-negative and decreasing. Put x equal to 2, 3, 4, so on. All terms are positive. And as denominator goes on increasing, function goes on decreasing. So condition justified over here, condition satisfied. Therefore, for all x greater than equals to 2, f of x is non-negative, monotonic, non-negative, monotonic decreasing. Function. Therefore, by Cauchy's integral test, Cauchy's integral test is applicable. Therefore, integral to infinity fx dx as x varies from 2 to infinity in summation. So x is positive. In integral, x varies from 2 to infinity, x is positive. So not necessary to write mod. It is integral of secant x. It is integral of secant x. Now see, secant is inverse of cos, infinity is inverse of 0. So secant inverse infinity, cos 0. Cos is 0 at what value? At pi by 2. Again see, secant is inverse of cos, 2 is inverse of 1 by 2. So cos inverse 1 by 2 is 60 degree. Cos has value 1 by 2 at 60 degree, and we have to write it in radians. We have to write it in radians. So it is pi by 3. Take LCM. Therefore, this integral is convergent, implies by Cauchy integral test, series is also convergent. Note, if some function is there with n, if some function is there with n, use Cauchy's integral test. Here tan inverse is applied on n. So Cauchy's integral test will be applied. If some special function like tan inverse or log comes with n, then you have to use Cauchy's integral test. Suppose it is f of n, replace n with x. Therefore, non-negative, monotonic, decreasing function of x. Therefore, Cauchy integral test is applicable. Value of x in denominator varies. Various values comes, so denominator is greater than numerator. Suppose if we put 1 over here, tan inverse 1, and in denominator we have 1 plus 1, 2. You can put different values to check whether it is increasing or decreasing. Tan inverse 1, what is its value? Pi by 4 in radians. Pi is 3.14 upon 4. It is less than 1. When you put 1, it becomes 2. Denominator is greater than numerator, so function is decreasing. Whenever denominator is greater than numerator, function is decreasing always. Derivative of tan inverse x is 1 over 1 plus x squared. There is one rule. If integral of f of x raised to power n into f of x dx, it's means derivative of f of x is present with it, integral of f of x raised to power n into f dash x. Its formula is f of x raised to power n plus 1 over n plus 1. See here, derivative of tan inverse x is present, so its formula will become, its power is 1, add 1 and divide the power. What we will get? One by 2 take common. tan inverse infinity pi by 2. Tan inverse 1 pi by 4. This is finite value. Therefore, by Cauchy's integral test, series UN is also convergent. Series is also convergent.